We would discuss different questions and different topics during this course. In this course, we would follow the order which is in the PDF guide. The exact order of the questions in the PDF guide is the order in which we would discuss things in this course. If you are interested in a specific section, then you can jump around to that specific video because that's the order we would take. For example, if you're not really interested in the basics and you would want to skip the first 20 questions, you can do that and you can move on to the other topics directly. We start off with the Java platform, JDK, JVM, JRE, platform dependence, and these kind of stuff. We would move into the basics like wrapper classes, strings. Java is an object-oriented language, and we would discuss the basics of object-oriented programming next. We discuss class, object, toString, equals, and a lot of other things during the subsequent sections. We will also talk about interface, abstraction, and constructors. We also discuss a few object-oriented concepts, the advanced object-oriented concepts like coupling, cohesion, polymorphism, encapsulation, inner classes, static inner classes, and anonymous class. Then we move into modifiers, the default class modifier, private, package access, protected, static, final, and all that kind of good stuff. After looking at a few examples on conditions and loops, we move into the all-important topic of exception handling. There are a lot of miscellaneous topics that we would cover as part of the miscellaneous topics section, at the end of which we move into collections. We also discuss about advanced collections like synchronized collection, concurrent collections, and things like that. Then we would move into topics like generics, multi-threading, and functional programming with lambda expressions and streams. We end the course by discussing the different new features which were introduced in various versions of Java. I recommend going through the PDF guide to understand the exact order of where the specific topic you are interested in might be discussed. The idea behind this video was to just give you an overview of the specific order in which we would discuss things in this course. If you take the PDF guide and spend some time with it, you should be able to easily figure out where a specific question might be. We are excited to start with the real questions in the next video. Until then, bye-bye. Welcome back. Let's start with the section on Java platform, and let's start with the first question. Why is Java so popular? There are a number of programming languages, C, C++, Java, and a lot of things which came after Java. Why is it that Java is the most popular of all the languages? Why is it that Java is the one which is used to develop enterprise applications for the big part? Not all applications are developed using Java, but a huge majority of the applications are built with Java. Why? The first reason why I think Java is very popular is because of its feature called platform independence. Once you have a Java executable, that's a jar file, you can run it on any operating system, whether it's Windows, Mac, or whatever operating system. So once you write a program somewhere, you can take it and run it in any place. That's platform independence, and that's one of the main reasons why Java is very popular. The other reason I think is because Java is an object-oriented language. Object-oriented programming results in much maintainable code than structured programming. We would discuss these two things in detail in later sections. I think the two reasons are basically platform independence and the fact that Java is an object-oriented programming language. The next question we would want to discuss is, what is platform independence and how does Java achieve it? Those are the two things we would discuss now. As we discussed in the previous question, platform independence is basically the fact that I can build a Java program anywhere and I would be able to run on any other operating system. That's basically what platform independence is. That's basically called build once, run anywhere. So you build it once, anywhere, whether it's Windows, whether it's Unix, whether it's Mac, you build it anywhere, and then you would be able to run that program in all other operating systems. The question is, how does Java achieve platform independence, right? So how does Java ensure that you are able to run your Java program anywhere? One of the important things to understand is that the executable code is different in different operating systems. The executable code in Unix is different from the executable code in Windows. However, the Java code that we write, typically we write Java code in .java files, right? So the Java code is the same. So with the same Java code, how are we able to get to different executable codes in different operating systems? That's the primary question with platform independence. The answer to that is in a Java concept called JVM, Java Virtual Machine. When I compile Java code, we get something called .class files. The .class files contain something called bytecode. Bytecode is basically a Java internal representation. The magic of the JVM is the fact that it can convert bytecode to executable instructions in that particular operating system. So a Unix JVM can convert bytecode to executable instructions on Unix. Windows JVM would be able to convert bytecode to executable instructions on Windows. And similarly, the JVMs in other operating systems. Basically, the fact is that the JVMs in different operating systems are different, but they are having one thing in common. That's basically the fact that they can understand Java bytecode. So the Java virtual machine basically converts the bytecode to executable instructions of that specific operating system. So Java achieves platform independence by having this intermediate format called bytecode, which is understandable by different JVMs. So the JVMs in different operating systems are able to understand this bytecode and convert the bytecode to executable instructions in that specific operating system. To summarize, Java achieves platform independence through two important concepts. One is the intermediate representation called the bytecode. Your .class files contain bytecode. The second important thing is the Java virtual machine. The Java virtual machine in any specific operating system will be able to convert bytecode to executable instructions of that operating system. So even though the executable instructions of Unix are different from that of Windows, the way Java achieves platform independence is having a different JVM for Unix and a different JVM for Windows. However, the common things for those two JVMs is the fact that they both understand bytecode, and they would convert this bytecode to the executable instructions of that specific operating system. There are different terminologies which are used around the Java development environment. You hear things like JDK, JRE, JVM. What are these? And what's the difference between each one of them? That's what we would discuss in this next question. When you talk about a Java program, what are the different things that you would do? You'd want to compile Java programs. So that's one. So that's basically you would want to be able to compile the Java code, create the class files or create the jar files and things like that. The second thing you would want to typically do is to run programs. So you would want to be able to take a Java class file and run it, or take a jar file and run it. So that's the second thing you would want to be able to do. Third thing you would typically do is also debug programs, right? You would want to check why something is not working. So you would need, if there's a performance problem, you would want to check if what's going wrong, how much memory is consumed, and things like that. So that's debugging problems or debugging programs. Those are the three things that you typically want to do when you're talking about Java programs. Think it from the perspective of the consumer. So there are two types of people who use the Java programs, right? One is developers. What do developers want to do? They would want to compile the code and run the code. And the other kind of consumers are the users. So whoever wants to just use these Java programs. So these guys don't really care about running they don't care about compiling the programs. They only want to use the compiled thing. So they want to be able to run the Java programs, let's say to play a game or something of that kind. That's why Java has two different things that are typically used: JDK and JRE. JDK is the Java development kit, JRE is the Java runtime environment. So if you want to run any compiled Java code, then all that you would need is the JRE. If my friend developed a game and he gives me a jar file, To run that, all that I would need is the Java runtime environment, because I don't want to compile and things like that. I don't want to debug. But if I'm interested in developing Java programs, then I need the JDK. So basically, you can think of JRE as the environment to run Java programs. So JRE is typically consisting of, at the base level, a JVM, Java Virtual Machine. As we discussed earlier, Java Virtual Machine converts the bytecode into executable code. So that's what the JVM does. Along with it, the JRE contains a list of libraries. Java comes up with a list of different library classes. You have a lot of classes in java.lang, you have a lot of collections and a lot of other classes which are present in Java. So you need all of them to be able to run the Java programs. So JRE would contain basically the JVM plus all the libraries which are associated with Java. JDK, in addition to the JRE, it contains the tools that developers would need. So JDK is Java Development Kit, and JDK would contain things like the Java C, that's basically to compile your code. And you have your jar thing. So you want to create a jar file, so you'd use the jar. And you have different debugging tools like performance things and things like that. So that's basically the JDK. Basically, to run Java programs, you need JRE. And to develop Java programs, you need JDK. Each one of these is a superset of the other. So JRE contains JVM, all JDKs contain JRE. So that's basically JDK versus JVM versus JRE. The next thing we would want to discuss is the differences between C++ and Java. The main difference between C++ and Java is the fact that Java is platform independent. You can write your Java programs on any operating system and take the compiled code and run it on any operating system. However, that's not the case with C++ because most of the versions of C++, when you run, when you compile the code, all that you would get is the object code. So C++ is not really platform independent. Both Java and C++ are not really pure object-oriented programming languages in the sense that Java has primitives. So it's not like all the primitives are not really objects. So it's not really object-oriented. And in C++, you can write structural programs. I mean, you can write C programs basically. You don't need to really use objects to write such programs. So both of these are not really pure, but in terms of purity, I mean, if you measure, let's say, 80% purity, 90% purity. So in that kind of a sense, Java is more object oriented than C++ because Java does not allow structural programming like C++ does. The other main difference is the fact that C++ has pointers, and pointers provide you a way to access what are the values which are present in memory and which could be a security problem in certain situations. Java has no concept called pointers. On the same lines, in C++, you have to allocate memory. So the programmer is responsible for allocating memory, deallocating memory, and things like that. In Java, no such thing. All that you need to say is new object, and that's it. When the object goes out of scope, the garbage collection kicks in and it would take the object out of memory. The other important difference is that C++ supports multiple inheritance. So you can extend two different classes from the same class. However, Java does not. The next thing we would want to discuss is the role of a class loader in Java. All Java programs are made up of classes. There are three different types of classes at a high level. One is the classes that you write as a programmer. The second ones are the classes that are in the frameworks that you use. For example, Spring, Struts, they come up with their own set of classes. And the third things are the classes with the Java environment directly provides. The system classes, the collection classes, and things like that. These are the different kinds of classes, and you need something to load these up when you are running the Java program. So when I'm running a Java program, I need to load all these classes. Java needs to find a specific class when I use it in the program. So who does that? That's basically the class loader. the class loader finds classes for us. There are three different kinds of class loaders based on where they would search for a class. You can think of class loader as something which searches the classes for us. And the types of class loaders are based on where they would search for that particular class. The three different types of class loaders are system, extension, and bootstrap. System class loader, extension class loader, and the bootstrap class loader. We would have all used this thing called class path. We would go and set a specific jar in the class path, things like that. The system class loader is responsible for loading classes from class path. So whenever you delegate finding a class to a system class loader, where does it search? It searches inside all the jars or all the folders which are mentioned in the class path. The extension class loader searches inside the extension directory. If you look at all JRE, JDK, they have this directory called ext. You have this ext, lib, and the JRE libraries. So you can see them in here, JRE, ext, lib. The extension class loader looks in those folders for any jars or classes. Bootstrap class loader is the ones which loads all the Java core files. Typically, the system class loader is the one which would load all the things on the class path. Typically, all the things in your jar, in your var, those are the things which are loaded by your system class loader. The extension class loader is basically where you are extending the existing Java and providing additional libraries. So that's basically library folders like JRE, ext, lib, and things like that. So that's your extension class loader. And the bootstrap class loader is basically your base Java classes. So now I want to find a class. What is the order in which these class loaders are run? Would bootstrap run first or would system class loader run first? Order in which classes are loaded are, it would start with the system class loader. So when I want to find a class, the JRE asks the system class loader, do you have this class with you? So the system class loader would search the class path and sees whether there is a class available with it. I don't have it. Then it would go to the extension class loader. Does it find it here? Based on whether it finds it here or not, it would go to the bootstrap class loader. If it still does not find the class with the bootstrap class loader, it would throw a familiar exception, class not found exception. So basically, if it's found with the system class loader, the class would be returned. Else it goes to the extension class loader. If it does not find it in the extension class loader, then it would go to the bootstrap class loader. That's the order in which the class loaders are executed. To summarize, class loaders are the things that load all the Java classes for us. And whenever the JRE wants to find a class, it goes to these. So it would go to the class loaders in the order of system, extension, and bootstrap. Let's move on to the next topic, wrapper classes. In the previous section, we looked at a lot of questions which are related to the Java platform. Java platform, along with the primitive variables, that basic int, float, and things like that, it provides certain things called wrapper classes. These wrapper classes are basically wrappers around the basic primitive variables. So you have the basic int, and integer is basically a wrapper class around that. Similarly, for all the primitive variable types, Java provides variable wrapper classes. So you have wrapper classes that's basically short, integer, and long. You have floating type variables, float and double, and you have a boolean, a byte, and a character. So those are the different wrapper classes that are present in Java. As we discussed earlier, a wrapper class basically wraps around a data type and gives it an appearance of an object. Also, it provides a lot of utility classes. So the question might be, why do we need wrapper classes? The wrapper classes have a lot of utility methods. So that would be one reason why you might need a wrapper class. Other than that, one of the reasons why you need to have a wrapper class is because if, let's say, a specific wrapper class object, you would want to put a value as null. For a primitive, the value can never be null. So that could be a possible reason. The other reason could be that you would want to use a wrapper class in a collection. So as you know, in all Java collections, they only support objects. and primitive classes are not really primitive types are not really objects. So you would not be able to add a primitive directly to a collection. Sometimes you might see code like hashmap.put key comma 5. It might look like a basic primitive variable, but actually what would happen is autoboxing. Autoboxing would take place and it would be converted into a wrapper class, and then that would be put into the collection. So effectively, in a collection, you would not be able to add a primitive value. To add a wrapper class, to add a primitive value into collection, it has to be a wrapper class. So that might be one reason why you might need to use a wrapper class. The other thing is you might want to use wrapper class to create objects from other types. For example, if I have a string value 55, I would want to convert it to a number. I can do that by using integer constructor, which accepts string as a argument. Those are the reasons why you might need wrapper classes in Java. The next thing which we want to discuss is the different ways of creating wrapper classes. How do you create wrapper classes? Wrapper classes can be created in a couple of different ways, basically. One is using the wrapper class constructor. So here you can see integer of 55 using a string, and you see how you can create floats as well in here. So that's basically the wrapper class constructor. And you see the other things, other constructors which are present in here. Character of C, which character do you want to use? And you have Boolean constructors, basically accepting any kind of strings as well. There are different kinds of constructors which are used to create these wrapper classes. The other things which are present in Java are also the value of methods. Each of these wrapper classes provide a value of method, which is a static method which can be used to create a wrapper class. The main difference between these two ways of creating wrapper classes is the fact that whenever you use a constructor, you are always creating a new object. So you always you always create a new object with the constructor. However, if you are using the value of static method like this one over here, then there's a chance that you might be using a cached value. So there's a chance that you might not really be using a new object all the time. So if I'm actually creating value between minus 128 and 127, there's a chance that if there are two such values, you would cache the value and return it back. If you look at this code here, you would understand this further. So this is the code which we picked up from inside the JDK for integer.value of. You're seeing that it's actually creating a cache. So what is happening is there's an integer cache created with a set of values, and when I'm searching for something between that range of values, what Java does is give the cached value. If it's outside that range, then it would return a new integer. To summarize, I would really prefer to use static value of method all the time, because it has a chance that you might save memory, because it would reuse the objects which are already there. Since wrapper classes are immutable, it's not a problem to reuse those values. Once a wrapper class is created, you would not be able to change the value of it. So since they're immutable, you'd be able to easily reuse the references to them without worrying that the value there would change. So to summarize, you can create a wrapper class using a constructor or the value of. The value of is a better approach because it kinds of caches a set of values and reuses objects for them. What is autoboxing? The definition you are looking at here would say autoboxing is automatic conversion the Java compiler does between primitive types and their corresponding wrapper objects. What does that mean? Basically, what it means is when I'm creating an integer, look at this line of code. So I'm taking a value 9 and assigning it to an integer wrapper class. What happens is this primitive integer 9 is automatically wrapped and converted into a wrapper class. Typically, the value of methods would be used. So it's almost similar to integer.value of 9. So it creates an integer and returns it back. So in the example like the one below, integer 10, I'm doing a 10 plus plus. This 10 is not really a primitive variable, so 10 plus plus in earlier versions of Java would have thrown a compilation error. But after Java 5, what it does is it would autobox, convert it, and increment the value which is present in the integer. I like the fact that this is really a funny example because I'm having a value of 10 here. I'm doing a 10 plus plus So the value of 10 would be 11. Don't worry about it. The example was not really a great coding example, I would say, but it's just to illustrate the concept of autoboxing, the fact that you can do a 10 plus plus on a wrapper integer. What are the advantages of autoboxing? The thing is, with autoboxing, we would use the value of method. So the static value of methods would be used to create object. So when I do integer 9c is equal to 9, what would happen is integer 9c is equal to integer dot value of 9. And as we discussed earlier, the value of methods would look at the cache and see if there is a similar object. If there is the same object present, then it would reuse the object instead of creating another object. So that's what you'd see here in this example. So if I'm doing a new integer of 9 twice, what you would see is both are not the same object. They're equal, but they are not the same object. They are two different objects. And here when I do 9c is equal to 9, 9d is equal to 9, they are both the same objects. So since they are the same object, they are equal as well. So that's basically the biggest advantage of autoboxing. Autoboxing reuses the wrapper objects which are already created, so it's better to go for autoboxing. The next thing we would want to discuss is what is casting. Basically, casting is typically used when you want to convert one data type into another. Basically, when you look at casting, there are two types. One is implicit and explicit. Implicit casting is automatically done by the compiler. For example, I'm saying long number is equal to value. Value is typically if you look at it here, it's an integer value. However, the Java compiler would implicitly cast this 100 to a long and then store the value in number. Similarly, when we do float f is equal to 100, 100 is a number and we are storing it into a float. So it's automatically converted into a float and stored in the float value. This is implicit casting. Typically, implicit castings are done when you are doing the automatic widening conversions. Okay, typical technical jargon. So basically, when you're storing smaller values into larger integer values. So I'm storing an int into a long, an int or a byte into a float. So these are widening. So this is small, this is big. So in those kind of things, implicit casting is automatically done by the compiler. Explicit casting is the casting which we do through code. So basically all the explicit castings are typically narrowing conversions. So what does that mean? So I'm taking a long and assigning it to an int. Without this int here, the code will not compile because number one is a long, number two is an int, and you cannot take a long value and store it to an int. So this is basically me telling the compiler that don't worry, the value in this, I know it's bigger, there's a possibility that there's a large value in here than the integer, but don't worry, I'll take the responsibility for it. You go ahead and cast it to a number or to a int. So similarly here, so with a float value as well, so I'm putting 35.35 which is a float. So what would happen is this would be cast to an integer and stored into the int variable which is present in here. As you guess, this would involve a truncation because I cannot store 35.35 or 35.35 if I have to pronounce it correctly. I cannot store 35.35 into the variable x because it's an int variable. I can only store 35. So what happens is 35.35 becomes 35 and that's what would be stored into an int. In this step, we started with the basic wrapper classes. We looked at how we create them. We looked at what's the difference between a constructor and a static value of method. And we looked at autoboxing and the advantages of autoboxing, as well as implicit and explicit casting. Until the next step, bye-bye. The next topic we are going to discuss is strings. So this is kind of one of the favorite topics of interviewers, strings. We would look at a few questions related to strings in this step. So one of the favorite topics to discuss is immutability. Immutability of strings. Are all strings immutable? Yes, they are. What does immutability mean? As we looked at the case of wrapper classes, for an immutable class, any instances of that particular class, once you have created an object, its value cannot be changed. So basically what it means is that once a string object is created, you can never modify the value of that particular object. So you might ask, I have a concat method inside this string. So on an instance of string, I can call the concat method. Is it not really concatenating that value to this value and changing the value inside that? The answer to that is no. What the string.concat method does is actually create a new string with the concatenated value. Whatever string reference contain the value as value 1, whatever string reference contain the value of value 2, or the string object which contains the value of value 2, they would remain containing the same values. What would be created is a new instance, or a new instance of string which would have the value 1, value 2. So that would be a new instance which would be created, but the existing value of string 3 would remain value 1. I'm opening up the java.lang.string class and looking at the different methods which are present in here. If you look at all the methods which are present in the string class, the ones which we typically use to modify, or ones which we think would be typically used to modify this string, you'd see concat, it returns a string back. Replace returns a string back. So the original string will not be changed. A new string will be created and that would be returned back. Same with substring. It would only create a new string with that substring and return it back. The original value of this string remains unchanged. Same is the case with two lowercase and two uppercase methods which are present right below. So if you look at all the methods which are there to modify the string values, they don't really modify the string value. They would just create a new string with the changed value and return that back. The original string whichever you had passed to that particular the original string on which that particular method is invoked will remain unchanged. This is because the string objects are immutable. You can never change the value of a string variable or a string object once it's created. You can change references, but the actual object value you will never be able to change. The next thing we want to discuss is where are string values actually stored in memory? This is a tricky question because this is quite variable with different versions of Java. So with different versions of Java, this has been changing. The answer which I'm giving would be particular to Java 7, and I guess it would remain same in later versions of Java, but I can never be sure. The way the string variables are stored, or the string values are stored, is basically whenever you are creating something like this, we are using something called a value. So this would actually be stored in something called a string constant pool. The string constant pool is present inside the heap memory. What it does, what the compiler does, is it looks for this in the string constant pool. If it exists, it is reused. So for example, if I'm creating another variable by the name string5 is equal to value, then what would happen is the existing value from the string constant pool is reused. However, if I'm using a new string, then this would definitely create a string object on the heap. It will not try to reuse the value. What it does is it would try and it would definitely create a new object and put it on the heap. So these are the two approaches, and always you'd prefer to not use a new string with a string because you would want to reuse them. A number of times you'd hear about not using a string concatenation operator in loops. Why? The reason why you don't want to use a string concatenation operator, or even for that matter string.concat method, is because each time you do a concatenation, you're creating a new object. So for example, in this particular loop that we are looking at here, this loop is running for almost 100,000 times, or if you are an Indian, it's running for 1 lakh times. For each of those 100,000 times, what we are doing is we are creating new objects. So we are creating actually more than 100,000 string literals in here. That's the reason. So you are creating 100,000 string objects and adding to it. So this basically creates about 100,000 objects, which is really a lot of objects. So that's the reason why when you're looping or you're modifying a lot of string values in a loop, it's recommended that you go and use a string builder or a string buffer depending on your thread kind of situations. So string is not a good idea to use when you want to modify the value of that particular string multiple times, like in a situation like a loop. This would have a great performance impact. How do you solve the above problem? One of the ways is to use string buffer. String buffer is thread safe, so it would bring its own overhead. If you're not really looking at a thread safe version, you can go for a string builder. But you can look at this example here. So string buffer, I'm using a string buffer instead of a string, and appending to this string buffer always. So this is a unit test which we ran. So if you really want to look at that specific unit test, you can do that. There's a test called string versus string buffer. You can look this up on the Git repository, or if you have set it up locally, you can look it at there too. So when we ran this test with string buffer, it took 0.4 seconds. So it's less than half a second. However, when we ran this with a string, it took 25 seconds. That's a difference of almost 50 times in performance. So be careful when you're using strings for concatenation or doing any value modifications on the string. Make sure that you're not doing it in a loop or a repeated kind of scenario. Okay, now let's get to the favorite questions. Some of the favorite questions actually. What is the difference between string and string buffer? I guess in most of the less experienced Java developer interviews, this would be a standard question. The most important fact is that the objects of type string are immutable. You cannot change the value once an object is created. However, string buffer, you'd be able to change the value of that particular object. Like in the situation where we saw before, when a value of a string is modified multiple times, then string buffer has performance benefits. Both string and string buffer are thread safe, and string buffer is actually implemented by using synchronized keyword on all the methods. So using the synchronized keyword is what makes string buffer thread safe. So even though you're changing the value of the string buffer, because we use string synchronized keyword on the methods, they cannot be concurrently modified by different threads. So thereby it's thread safe. The other favorite question is string builder versus string buffer. It's basically string builder is not thread safe. So that means if same object is referenced by two different threads, then thread safety is not really guaranteed. So that's the main difference between string builder and string buffer. A few of the utility methods in string, you can look at them in here. So there are a few things on the screen: length, toString, equals ignore case, substring, and all that kind of stuff. One of the exercises you might want to do is take the string versus string buffer example. As I said before, all the examples are on a GitHub repository, Java interview questions and answers. So you can just look at our Git repository in 28 minutes. You should be able to easily find the Java interview questions and answers repository, and you would find a class called string versus string buffer in there. So you can run this test. So this would give you a good example of the performance between string and string buffer. You can add string builder as well and see what kind of a performance difference it brings in. This is a simple test with no threading kind of thing, so the performance might be the same for string buffer and string builder, but you can really play around with it. And the other example we would recommend for you to look at is the string examples. So try and spend some time with it. It has a lot of examples of string, and you can try and understand the string thing in detail. There are the first two exercises for you as part of this course. Until next step, bye bye.